This video is part one of a two-part series on the design and development of a fully automated Accu-Slice system. I began by taking my two previous controllers that I used in my previous videos on automating the Accu-Slice system and then combined the various features here into a single controller that would be needed to operate the Accu-Slice system. In other words, I added some additional features, but I also subtracted a few features from this new controller box. The one feature I did add is a fully automated operation of the Accu-Slice system. In other words, I want the operator to be able to input the number of cuts he wants to take on a board, and then the system will automatically make those cuts without any operator input. I began the design by, first of all, designing the front panel of the new controller. This will contain the various buttons and features that are needed to operate the system. I next designed the electronics for the system with all the components that would be needed in the system, and I put these into a prototype which I developed here on my desktop. It's all mounted on a breadboard with an Arduino Mega controller, stepper motors and stepper drivers, LEDs, and push button switches. So everything is there to test the system and develop the software. Before I could actually start developing the software, I actually drew up an outline of the various features and components that would be needed in the software and a logical progression of those features in the software. I'll be using this document then to write the software for the system. The next section of this video will describe these documents in some detail and also demonstrate the Accu-Slice automated system software in some detail. At the end of that video, we'll come back here and we'll show the actual operation of the system on my breadboard design system. I began this project with the design of the front panel for this new controller. I combined the components of the two previous controllers in order to provide for the systems that will be required for this new controller. In the center section, I've added the run and stop buttons, which will control the semi-automated running of the Accu-Slice system. I also included the left jog and right jog controls to enable the movement of the carriage during initial setup. I added LED lights on all sections of this panel to display the operating condition of each of the components. In the center section, I added the new Auto Run button. This is a new fully automated system to permit the continuous cutting of multiple slices of boards from the board mounted to the carriage. In the far left box, I added the magnets. I replaced the mag jig clamps with electromagnets to enable the automatic activation of the magnets when needed for the operation of the system. In the far right box, I've added the controls for the indexer. The run button advances the indexer, the thickness of the board you want to cut, plus the bandsaw blade curve. The reverse button will rapidly reverse the index to the starting position. The top left box contains a potentiometer and enter button for inputting data into the software for the operation of the system, including the blade curve, thickness of the board you want to cut, and the speeds of operation. It's also used to input the number of slices to cut for the fully automated operation program. The top far right box contains a reset button to restart the program and an emergency stop. The top center display is a 4-line LCD display for listing the system parameters and the status of operations. Likewise, I designed the back panel for this controller. It contains outputs for the stepper motors, the 2 Hall limit switches, and the 2 magnets. It also includes the power input with an on-off switch and an input for the USB for the Adruino board. Next, I designed the electronics and circuit control for this project. I began with the Arduino board. I had to go to an Arduino Mega board because I needed more inputs and outputs because of the number required for this project. The system consists of the LCD display, a power supply, 2 stepper motors with 2 drivers, 2 electromagnets, 8 LEDs, a potentiometer, a reset button, and 11 push button inputs. I began by outlining the design of the software that will be required to operate the system utilizing the Arduino software. The program turned out to be quite complex, since I'm running multiple programs, subprograms, or subroutines in order to enable the manual operation of the system components, the semi-automated operation of the Accu-Slice system, and a fully automated operation of the system. It will be critical to design the software so that the various software routines are separate from one another and that any subprogram does not interfere with any other program sections of the program. In the first part of Adruino software, I defined the stepper motor library and LCD libraries that are required to operate the systems. I also defined all of the LEDs and push buttons that will be needed to operate the system. In the setup section of the program, I initialize the 4-line by 20 character LCD display, set up the stepper motor parameters, and further define all the LEDs and push buttons. Since the programs in this section only run once, I included the software program steps to input data for the board thickness you want to cut, the bandsaw blade curve, the forward speed of the board and carriage for cutting boards on the bandsaw, and the reverse speed of the carriage to return the carriage to its starting position. This next outline describes the various subroutines that are used to operate the various operations and functions. I begin with the indexer routines. A push button will advance the indexer the thickness of the board you want to cut, plus the thickness of the bandsaw blade curve. This data was entered manually in the setup routine. The indexer reverse button is then used to rapidly reverse the indexer to its starting position. The jog right and jog left buttons will move the carriage back and forth and are used to initially set up the Accu-Slice system for your first cut on the board. A magnet button will permit the manual activation of electromagnets for the Accu-Slice system. The magnets are later automatically controlled via the software, such that any time the carriage is moving, the electromagnets will be activated, and then deactivated when the carriage movement stops, so no need to worry about turning them off and on. The run program will run the board through the bandsaw blade, activate the electromagnets, and then stop when the hall sensor is activated. It will then automatically reverse the carriage to the starting position. A stop button is used to stop the operation at any time during the operation of the system. The automated section of this program permits the continuous operation of the Accu-Slice system to cut multiple slices off a larger board continuously without any operator input. The operation begins with the input by the user with the number of slices or cuts that will be required. The program then activates the electromagnets and begins the first cut. When it senses the hall sensor, it reverses direction at the higher speed until it reaches the start position. The indexer is then started to advance the board for the next cut, and the cutting operations continue until the number of cuts set up has been reached. The system then resets itself for further operations. Again, an emergency stop button is included in the software. I'll be describing the software in some detail should you wish to build your own version of the automated Accu-Slice system. This software program is the current version after the initial design and testing using a mock-up version of the hardware using a breadboard with the major hardware components running on my PC computer. The software will be further modified after I've designed and built the electronics console and tested it on the actual Accu-Slice system mounted on the bandsaw. I do expect some significant changes after that testing. A final version of the software will be available on our website or to anyone who requests it. In the Initialization section of the software, I define the A-cell stepper library that will be used to control the stepper motors, the liquid crystal library, which is used to control the LCD display. The input for the potentiometer was set to analog input A sub 0 on the Adruino board. Next, I define the various push buttons that will be used to operate the system. These include the inner button, which is used to input data selected from the potentiometer. The other button names are self-evident and were previously described in the beginning of this video. I also described the various LEDs that are planned for this program. Finally, I described the variables to be used to control the bandsaw blade thickness or kerf, the board thickness of the board you want to cut, the forward speed during normal operation, as well as the reverse speed. In the setup section of the software, I set the parameters for the stepper motors. Note that stepper 1 will be used to operate the indexer, and stepper 2 will be used for the linear travel of the carriage. I then describe the modes for the various momentary buttons or switches used in the program. I define these buttons as input pull-up modes so that I can use the internal resistors in the Arduino software, and I do not need to add an external resistor to the hardware. I then further define the mode of the LEDs as output devices. The setup section of the software only runs once and does not recycle and repeat itself. I therefore chose to run the program for inputting the thickness of the board to be cut and the bandsaw blade curve and the speed of operation of the carriage into this section of the program. The potentiometer is used to adjust the value of these parameters, and the inner button is used to save the value into the program. The value read by the program is recorded in the variable board pot. I first will enter the thickness of the board to be sliced. Using the value of the potentiometer variable board pot divided by 5,000 enables the selection of board thicknesses to be cut from 0 to 0.2000 inches, which is stored in the variable board T. Note that I'm reading and recording values to 4 decimal places in order to get more accurate values. This value is entered and displayed on the first line of the LCD display. Next, the thickness of the bandsaw blade kerf is entered. This value is normally between 45 thousandths and 55 thousandths of an inch. Using the value of board pot enables me to enter values between 0 and 0.1000 inches for the blade kerf. This value is stored with the variable blade kerf. The blade kerf is displayed on the second line of the LCD display. Data for both of these board thicknesses and bandsaw blade kerf are in inches, but could easily be changed to millimeters or other dimensions. The third value to be entered is for the speed of the bandsaw blade in inches per minute. This will be the speed at which the board to be cut is fed into the bandsaw blade. Based on my previous testing of this system, I found that the slower you cut, the smoother the cuts. Speeds between 10 inches per minute and 30 inches per minute give the best results. The forward speed read by the potentiometer is the analog read of the board pot divided by 25, which enables the input of speeds from a 0 to a maximum of 40 inches per minute. The value entered is stored in the variable forward speed and is displayed on line 3 of the LCD display. Normally I will be cutting at speeds between 10 and 25 inches per minute. The fourth and final value entered will be the reverse speed of the carriage, which is the speed at which the carriage returns after completing a cut. In order to save time, I want the carriage to return much faster than when I cut the board. Using the value of the board pot divided by 10.25 will enable the input of speeds from 10 to 100 inches per minute. I normally return the carriage at a speed between 50 and 100 inches per minute. The value of the return speed is saved into the variable reverse speed and displayed on the fourth line of the LCD display. The initial status of the LEDs is then set, and other variables are set to a starting value of 0. The main loop of the software program runs continuously, cycling back and forth from the beginning to the end. This section of the program contains all the subroutines or subprograms for the operation of each function required for the Accu-Slice system. Since I want to enable the manual operation of several sections of the program, such as the jogging of the carriage and the moving the indexer, as well as the semi-automated operation of the carriage by the run program, and finally the fully automated operation of the Accu-Slice system, it's important to design the software so that each of the program sections can be run independent of one another and without interference from other sections of the program. In my initial design of this software to control the automated Accu-Slice system, I wrote the entire program into this loop. This turned out to be quite involved since I had to design the software so that the various program components did not interfere with one another. So I've recently redesigned the entire software using subroutines or functions. These subroutines are stored in a separate location in the program and are just called up when they are needed for an application. This main section of the program or loop of the software will just define the applications needed and then call the subroutines as they are needed. As shown in this main loop of the program, I will be designing 8 separate subroutines for the operation of the Accu-Slice system. This first subprogram is the indexer routine, which advances the indexer the distance of the bandsaw blade kerf plus the thickness of the board to be cut. When the index button on the console is pushed, this index subroutine is called and runs. Here's the index subroutine. It turns on the various LEDs, turns off the electromagnets, and then advances the index by the predetermined distance. The next subroutine is the index reverse program. Again, when the index reverse button on the console is pushed and held down, the index reverse subroutine is called and runs. Again, the subroutine turns on the LEDs, turns off the electromagnets, and reverses the index as long as the push button is held down. The next 2 subroutines are for the left and right jogging of the Accu-Slice carriage and operate in the same manner as the reverse indexer described above. When the control panel button is pushed and held down, the carriage moves to the left or right. This feature is used in setting up the Accu-Slice system for the first board cut. The next 2 programs are for the manual operation of the electromagnets. The mag jigs on the Accu-Slice system are replaced with these electromagnets, in order that I could fully automate the Accu-Slice system. The first subroutine turns on the two magnets, and the second subroutine turns them off. The electromagnets can be operated manually, but their status is overwritten when operating the automated Accu-Slice system and in the run mode, and also when moving the indexer. Since they are fully automated, there is no need to turn them off and on with every run. The next two subroutines are for the run mode and the automatic mode of operation. These are the heart of the software. The first routine, called the run mode, controls the linear travel of the carriage through the bandsaw blade. The speeds of operation were set up in the initial part of this program. This section of the software operates the system in a semi-automated mode. It first turns on and off the appropriate LEDs. It then activates the electromagnets. It then runs the carriage and board through the bandsaw blade until the hall sensor at the end is reached. It then reverses the direction of the carriage to return the carriage to the starting position, which is again sensed by an additional hall sensor. When it reaches the starting position hall sensor, the direction of movement is again reversed, and the carriage moves to the right until it is just out of range of the hall sensor. It then activates the index subroutine to advance the board for the next cut. A stop routine can stop the travel any time in case of an emergency. Finally, some system parameters are printed to the LCD display. These are mainly used in a fully automated mode, which I will describe next. The final program section in the main loop is for the fully automated operation of the automated Accu-Slice system. The first subroutine that is called is for the input of the quantity of boards that you want to cut off a thicker starting board. This subroutine requests an input for the number of board slices that you want. The quantity is input via the potentiometer. As you input the quantity you want to cut, the LCD display also indicates the thickness of the board that will be required to complete the slicing of all the parts. This data has been calculated by multiplying the number of cuts times the sum of the board thicknesses and the blade curve. This is to help ensure that you have enough thickness of board to slice so you do not cut into the sacrificial fence or carriage. Back in the main program section, it calls for the run carriage subroutine. This is the same routine that was used for the normal run operation described previously. So once again, it runs the board through the bandsaw blade, reverses it to the starting position, and advances the indexer for the next cut. The LCD display indicates the number of cuts remaining, and the system proceeds to cut the boards until all have been cut. The emergency or stop program is active throughout the running operation to stop the program for any reason or for an emergency. When the final board has been cut, the system stops, and the LCD display is cleared for further operation. As I stated earlier, this is just the initial development of the software program for the automated Accu-Slice system. It was developed using a mock-up of the system components on a breadboard on my PC. Next, I will demonstrate some of the operations described here utilizing this mocked-up design. Now that we described the software in some detail, let me show you how it actually operates on my breadboard setup design. These are the various components of the system, starting with my Arduino Mega controller. Then I have two stepper drivers. I have two stepper motors over here. I have various push buttons that are used to operate the system. LEDs that will be used to demonstrate the status of the system. I have a potentiometer here, which is used to input data. And I have a relay here, which is used with my electromagnet. So first of all, I just initialized the program, and it's asking for what thickness of board you want. This is the thickness of the board you want to cut. And then you use a potentiometer to dial in that thickness. So in this case, I want a board to say it's going to be 50,000 of an inch thick. So I just dial in, to 50, and then press enter. Then it asks for the curve for the blade. Normally a blade curves around, say, 45,000. So you dial in, say, 45,000, and then press enter. Next, it asks for the forward speed. This is the feed that you want to feed the board through the bandsaw blade. And I normally find that speeds between 10 and 30 inches per minute work the best. So let's select 15 inches per minute and then enter. And then reverse speeds is the speed you want it to reverse back out of the bandsaw blade after the board's been cut. In other words, I don't want to reverse at the same speed I cut because I want to speed it up so I can make that go much faster. So maybe I'll have that at say 80 inches per minute and then press enter. And then there's my 4 parameters: my board thickness, my blade kerf, my forward speed, and my reverse speed. Then I have various modes of operation. To operate my indexer, for example, I press my index, and it advances my index, the set distance, which was set up here in the program. To reverse this index back to the starting point, I just press my reverse button from my indexer, and it takes it back to the starting point. Also, I have my jog positions for the index carriage. This is jog left and jog right. And again, they're just 2 buttons that cause the stepper motor to go either forward or reverse. I also have a button for the magnets to turn the magnet off and on manually. But the main buttons are the run mode and the auto mode. The run mode will, first of all, if I push the run mode, it starts a stepper motor which will advance the board until it hits the Hall sensor, which is right now is just a push button switch. So I push that. That stops it, reverses the motor. When it goes back to the starting point and senses a start, hits another sensor, and it stops. The indexer automatically advances to the correct position. It first of all runs the board through the bandsaw blade, reverses the direction, and then advances the indexer to the next cut. So it's a semi-automated operation. In the automated mode of operation, I push another button, and it asks me how many boards I want to cut. And again, I set that number via my potentiometer. So if I want to cut, 8 boards, well, it tells me I need a board thickness of 0.76 inches to make 8 cuts based on the parameters I put in. And if I wanted to do, just 5 cuts, then I need almost half an inch of board. So again, let's just get indication how much wood you need so you don't cut into your sacrificial fence. After that's been selected, you press enter, and then the system runs automatically. It starts the motor to advance the board to the bandsaw, sets the end, reverses it, stops it, advances the index wheel, says there's 4 more boards to cut, starts the next cut automatically. Again, same thing, sense in the end, stop it, going to the next board. Now it says I have 3 more to cut. It's starting that cut automatically. So it's going to automatically cut all 5 of these boards I put in there until it's done. And each time tell me how many more to cut. So I have 1 more board to cut. So it's already cutting. It's finished. Now it clears the screen and tells you the thickness of the board and the kerf for future operations. So that's the basic operation of the system. Next will be putting these components into an electronics console, building that console, attaching it to the bandsaw, and then testing it for the actual operation of the system. And I'm sure there'll be some additional modifications of software at that point, because there'll be bugs I haven't discovered yet that need to be changed. I may change some system parameters, so we'll see how that goes going forward. So until the next video, thank you for watching this video once again. If you have any questions or concerns or comments or even suggestions to improve the system, because it is still in development, I'd be happy to hear from you. So once again, thank you for watching this video. In the next video in this series, I'll be describing the design and development of the electronics console, and then attaching it to the Accu-Slice system on the bandsaw, and then demonstrating the operation of the system to cut multiple boards on the bandsaw.